Hello, myself Utkarsh Tyagi, working as Assistant Professor in School of Biotechnology, IFTM University, Moradabad. Today we are going to discuss UV-vis spectroscopy. UV-vis spectroscopy is a very widely used technique not only in chemistry lab but also in life sciences. Many different experiments rely on the idea of UV-vis spectroscopy. But the first question is, why we need this technique? If it is a technique, what this technique giving us? The answer is, in many situations we need to find concentration of different substances, molecules in a solution, and that we can measure perfectly by this UV-vis spectroscopy technique. In some situation, concentration of cell during the microbiology practicals, we can also use UV-vis spectroscopy, so it can give a good data about the concentration of any molecule is present in a solution. Let's start. Here we are going to discuss introduction, principle, instrumentation and application of UV-vis spectroscopy. Let's start with introduction. Spectroscopy is the interaction of electromagnetic radiation and the molecules or atom or ions of a sample. Electromagnetic radiation is the discrete package of energy which is also called photon. Photon consists of electric field and magnetic field which are perpendicular to each other. Here are some terms like frequency, wavelength. Frequency, which is denoted by nu, is defined as the number of times electric field radiation oscillate in 1 second, and the unit for frequency is hertz. Wavelength, denoted by lambda, is the distance between two nearest parts of the wave in the same phase. Electromagnetic radiation, the relationship between wavelength and frequency represented as C is equal to nu into lambda. Photon is subjected to energy E is equal to h nu, where h is Planck constant and c is speed of light. This is the overview of electromagnetic radiation. Here easily we can see that in the region of UV region, which comes around 200 to 400 nm, and visible region, this has come from 400 to 800 nm region. The basic principle of UV-vis spectroscopy. Spectroscopy is based on the interaction of light with matter. As light is absorbed by matter, the result is an increase in the energy content of the atom or molecules. When ultraviolet radiation are absorbed, this results in the excitation of the electron from the ground state toward a higher energy state. Molecules containing pi electron or non-bonding electron can absorb energy in the form of ultraviolet to excite these electrons to higher antibonding molecular orbitals. The more easily excited the electrons and the longer the wavelength of light it can absorb. There are four possible types of transition: pi to pi star, n to pi star, sigma to sigma star, and n to sigma star. The absorption of ultraviolet light by a chemical compound will produce a distinct spectrum which aids in the identification of the compound. UV-vis spectroscopy follows the Beer's and Lambert's law. The amount of light absorbed is directly proportional to the concentration of the absorbing substance and thickness of absorbing material. This law is expressed through this equation: A is equal to log I naught over I is equal to E into C into L, where A is absorbance, I naught is intensity of light upon a sample cell, I is intensity of light departing the sample cell, C is concentration of solute, L is length, E is molar absorptivity. There are many basic components of UV-vis spectroscopy, and the first one is light source. Tungsten filament lamp and hydrogen deuterium lamps are widely used and suitable light source as they cover the whole UV region. Tungsten filament lamp emits the radiation of 375 nm, while the intensity of hydrogen deuterium lamps emits below 375 nm. Next component is monochromator. Monochromator generally is composed of prism and slits. Most of the spectrophotometers are double beam spectrophotometers. The radiation emitted from the primary source is dispersed with the help of rotating prism. The various wavelengths of the light source, which are separated by the prism, are then selected by the slits, such as the rotation of the prism, result in a series of continuously increasing wavelength to pass through the slit for recording purpose. The beam selected by the slit is monochromatic and further divided into two beams with the help of another cell. Next component is a sample and reference cell holder. One of the two divided beam is passed through the sample solution and the second beam is passes through the reference solution. Both sample and reference solution are contained in the cell. These cells are made of either silica or quartz. Glass cannot be used for the cell as it also absorbs light in the UV region. Next one is detector. Generally, two photocells serve the purpose of detector in UV-vis spectroscopy. One of the photocell receives the beam from sample cell and the second detector receives the beam from the reference. The intensity of the radiation from the reference cell is stronger than the beam of a sample cell. This results in the generation of pulsating or alternating currents in the photocell. Next component is amplifier. The alternating current generated in the photocell is transferred to the amplifier. The amplifier is coupled to a small servometer. The main purpose of amplifier is to amplify the signals many times so we can get clear and recordable signals. Next component is a recording device. Most of the time amplifier is coupled to a pen recorder which is connected to the computer. Computer stores all the data generated and produces the spectrum of the desired compound. Next is applications. There are so many applications. Qualitative and quantitative analysis. It is used for characterizing aromatic compounds and it can also be used to find out a molar concentration of the solute. Detection of impurities in the organic solvent. Detection of isomers are possible. Determination of molecular weight using Beer law. And these are the references. This video PPT, I'm not making this video PPT for commercial purpose. This is only for student welfare. These are the references. Thank you.